Good afternoon, ladies and gentlemen. I'm happy to welcome you here in this cultural place. It's not a very common place for a conference. We hope we're going to enjoy the place. So just a few words, as of course I'm the initiator of Euradwaste, and this session is sort of a transition between this morning when we were talking about generally policies, and this session is about looking at the situation in the fields of reactor systems and radioactive waste management in terms of research, and then policy for research. So it's my pleasure also to welcome the chair, Mr. Euradwaste. He is the president of the Romanian Nuclear Agency for Radioactive Waste Management. He was the prefect for a region in Romania, Cosvana. He was also deputy quaestor, president of the Economic Commission within the Chamber of Deputies. And he also has a technical background. He has a mechanical engineering background. So just a small additional thing. There is a special present for each of the contributors, and it's my pleasure to offer them to all the chair and then the speakers. Thank you very much for accepting. Massimo. And then to Hans Forsström, my former boss for 7 years at the European Commission, and he was also director at IEA for 5 years before retirement, but he's still very active. Okay.
Thank you, Mr. Christoph Davies. Ladies and gentlemen, honorable assistants, your excellencies, I am Horia Grama, president of Nuclear Agency and for Radioactive Waste from Romania. I am pleased to chair the afternoon Euradwaste session named International Europe Euratom Status in Radiation Protection, Safety of Reactor System and Radioactive Waste Management. Let me begin my remarks today by thanking those who work so hard to organize this conference. It is a great honor to co-chair this panel with Mr. Massimo Gariba, Director Nuclear Energy European Commission, and to have the opportunity to thank him for demonstrating with his presence here the importance he placed on the issue addressed at this conference. Also thanks to Mr. Hans Forsström, Senior Advisor at CKB International Sweden, and great specialist in nuclear, which is our rapporteur. I'm equally pleased to introduce each speaker of the panel. And I want to tell you the panel is structured in 3 parts: status of EU Euratom directives, radioactive waste management, safety of reactor systems. The Euratom Treaty provides the legal framework to ensure a safe and sustainable use of peaceful nuclear energy across Europe and help non-EU countries meet equally high standards of safety and radiation protection, safeguards and security. Nuclear Safety Directive, as well as the directive that establish a community framework for the responsible and safe management of spent nuclear fuel and radioactive waste, and the directive laying down basic safety standards for protection against danger arising from exposure to ionizing radiation, all of them set out objectives and policy that EU members need to attain. Nuclear energy is the only expendable source of large-scale electricity that does not generate CO2 emissions. Safety of a reactor is of prime concern to ensure the safety of public, the reactor operators, and the investment itself. Also, to assure the safe, technically optimal and cost-effective management of spent fuel and radioactive waste, appropriate policies and strategies are required, and effective infrastructure need to be developed. I'm certain that we can meet any challenge if we come together in a common purpose. This conference is a very good framework to find our way together. Now, let me start our panel conference with the status of EU Euratom directives. And I invite Mr. Michael Hebel from the European Commission, Direction of Energy, which is head of unit, radiation protection and nuclear safety, to keep his presentation. Sir, you have the floor.
Good afternoon. Thank you very much for the opportunity, for the great honor to be able to speak here today. I'm very happy the presents were given out before the speeches were given, for two reasons. First, because in audiences like this, I'm not sure who knows more about the directives. Parts of the audience are myself, because some of you have been working, some of you have been writing the directives. So there is a bit of an issue there. And secondly, because probably our perspective of the directives is different from a research perspective on the directives, different from a regulatory perspective on the directives, and perhaps also different from an approach of people who have to implement then afterwards on the ground many elements of what we are regulating. So the idea status of the directives, I try to translate a little bit in trying to run through main features, at least for me, for the Nuclear Safety Directive and for the basic safety standards and radiation protection, but really try to stop at points where we sort of feel that, let's say, in many dimensions, work may still be needed, and work also from the community represented in the two conferences here may still be needed. So it is obvious that we're talking just about a part of what Euratom regulates, but we're talking about a very important part, and in the case of radiation protection, about one of the founding areas, really, of the Euratom Treaty. But if you look at the developments of the legal framework at EU level, it is also clear that there was quite a massive development of the legal framework since 2009, and clearly since Fukushima, then shortly afterwards. You see in short succession the first directive on nuclear safety adopted after a long discussion, a long fight, legal proceedings around whether there is a role of Euratom in this field or not. The waste directive then, the smaller directive, the specific directive on drinking water, and then the revised basic safety standards directive and the amended nuclear safety directive, and I'll come back to these two, which are my task to present today during the course of the presentation. So on nuclear safety, really the link to the Fukushima accident is quite important. And when the European Council met shortly after Fukushima, looking at the impact and the response to be given at EU level, it gave two tasks, really, two mandates. It gave a mandate to look very quickly through the system of stress tests at the situation of nuclear power plants and installations in operation in the European Union. and it gave the mandate to review the legal and regulatory framework for nuclear safety. And that's quite significant because obviously the directive, the new Nuclear Safety Directive adopted in 2009, 2 years later, the European Council says, you may want to go back and review, and you will find that the amendment of the Nuclear Safety Directive as a result has actually strengthened the directive compared to the original directive in important instances. And that's quite important at the stage today when we look at how member states have actually transposed, how have member states actually put this particular piece of law into their legal framework. So the stress tests took place. Action plans were developed. There's regular reporting on the action plans. Some of it is not completed yet, but a great lot of it is completed. The Nuclear Safety Directive then, in its amendment, and probably in the middle of the Nuclear Safety Directive, the idea of continuous improvement of nuclear safety. And the slide shows, and I will, as I say, in the short time here, go very, very quickly to an audience which is, of course, aware that the introduction of the safety objective clearly was an innovation of the new directive, the idea of the peer reviews, different kinds of peer reviews, but also the topical peer reviews, stress test-like reviews which were introduced into the directive, the notion of nuclear safety culture, provisions on emergency preparedness and response, which were new here and link up to provisions on the BSS, to which we come back later, and of course the notion of the independence of the regulatory authority and the ideas of transparency, which were strengthened by this directive. Now, this is it. Perhaps someone can just change the slides, that would be very kind. Okay, thank you. So the nuclear safety objective, as I say, as this sort of notion in the middle of this new piece of law, which looks at this sort of continuous process of improvement, which goes through all the different stages of the development of the plant, from the design to decommissioning, the idea of preventing accidents, the idea of mitigating the consequences of accidents, and the idea of this staged approach where we look in different ways at existing and at new installations, but also for the existing installations, the expectation that there is the continuous improvement of safety towards the best possible achievable situation. Now, again, different elements as provided for the safety objectives. And as you can imagine, I mean, jumping to what is probably more interesting for you when we now look at the transposition of the directive in the member states, you know, the directive is due to be transposed. The member states have by and large declared transposition to varying degrees. So we're now looking very closely at what is happening. It is clear that behind a lot of these concepts which we saw on the previous slides, the role and the independence of the regulator, the implementation of the safety objective, the exact provisions around the assessments and peer reviews, the provisions around transparency, we are looking very closely at what is going on, and we have to obviously legally operationalize some of these concepts which are fairly general in the text of the directive. But it's not all theory. We have already launched through NSREC the first of the topical peer reviews. Topical peer reviews take place every 6 years. This first one was dealing with aging, and you will probably be aware that the report was published just last October, and national implementation reports are now due to be developed, which will be followed up in a similar way as the stress test reports will be followed up. It's important to draw lessons, of course, from a first application of the peer review, and this is something which will be done in time for the next peer review to start. But it's also very clear that the process of transparent follow-up of the different findings of the peer reviews of what are the commitments in the action plan will be will be very important. Now, sometimes it changes, sometimes it doesn't. And if you look at some of the findings and challenges, which show that there are quite significant differences in the national approaches, even though all member states, I'm sorry for turning around, it's the only way to see the slides and the audience at the same time, all the member states have aging management plans in place, but we see a lot of difference. We see a particular issue around some of the older research reactors. In some countries, we have seen in the report challenges on the evaluation of the programs, but clearly the international peer reviews, the link to the IRS and to Artemis then from the waste side are seen as a good practice. And as I said, it's now the time to present the national reports. So the Nuclear Safety Directive, a very political directive, strengthened, and a directive where we are now in the middle of the checks in member states, our legal responsibility as the Commission as far as the transposition into national laws and regulations are concerned. I cannot give you the outcome of that process, but I can tell you that it's a very thorough and intensive process with the authorities of the member states looking very deeply into the functioning of the systems. We're looking not just at laws, we're looking at implementing regulations, at guidelines, at practices. We are getting citizens writing in, speaking about nuclear safety, and we use that information as part of the discussion. So it's a very intensive process where we're in the middle of at the moment. So on radiation protection, as I say, a very old competence. So we're talking about something different here. I mean, the legal challenge of the new BSS, on the one hand, is that obviously a lot of what is in the directive is not new in radiation protection, but it has all been put into one document, into one common framework, which is good because it gives one legal place where radiation protection provisions are being put together. And it is difficult at the same time because if you then give this directive and you say to member states, this is the new directive, please implement, please transpose it, it sort of looks like a huge and a very, very big task ahead of everybody. So the 2013 revision, apart from putting everything together and in this way trying to facilitate the application of radiation protection at EU level, and you see the different provisions set out at the bottom of the slides, or you don't see them, but I think the slides are available, was also to look at the development of science since 1996. So the safety standards directives come in a bit of a 10-15 year rhythm. It covers now all radiation sources. We wanted to cover natural radiation, and there are provisions on radon, covers all exposure situations, and it integrates, as I said, the different dimensions, workers, members of the public, patients, or the medical area into one legal framework. So I want to highlight really a couple of areas out of the BSS because we think that these are areas where there is probably also quite a bit of research interest in taking work forward. And one of these obviously is the medical field. This is not the first time we're regulating medical exposures. I mean, there has been a specific directive for medical exposures, which has been in place, and a lot of the provisions in the BSS actually are provisions which have been taken from that previous directive. But there have been a few important changes, and there is clearly also now with the new directive and with more attention on radiation protection, a very important need to bring together the health and the radiation protection dimensions in the application of the directive. What I mean is that when you speak about the protection of workers, probably about the general public. In many areas, there's the one radiation protection authority in the country, which is charged, which is able to issue specific provisions for the country, even in the cases of particular incidents. The medical field is different. It's a different world. And medical applications are being done, as you know, for the good of a patient, if all goes well. And it's a different mindset. And at the same time, the directive puts, this is just to show the variety of application of radiation in medicine, as well as the importance of medical applications for public exposure. But this variety of application is just an indication of what I was talking about. But if you look at the main changes of the BSS in the medical field, particularly linked to changes in the justification and optimization of medical practices, this by the health sector is seen as a new dimension of the development of guidelines, of the dimension of clinical care, of patient safety. And an important task we are having for the moment at our level is to bring these discussions together, because there's a discussion about evidence medicine, obviously, about guidelines, about appropriate treatment in health, and we have a discussion on optimized and justified treatment with radiation. So it's important to bring these discussions together, and there may actually be, even from the angle of the radiation protection research, an interest to reach out to health research to bring some of this a bit closer together. In order to facilitate that process, some of you may have heard this acronym of SAMIRA, the Strategic Agenda of Medical, Industrial and Research Applications of Radiation and Nuclear Technologies. And our idea with the SAMIRA process, we had a couple of conferences, we had a number of studies, we spoke to stakeholders, is to look towards the new mandate of the Commission at an agenda of issues which are areas where the European Union could add value to perhaps on the one hand to promote some of the non-power applications, but also to do that in full recognition of radiation protection and other safety requirements. And I think that echoes well with what we heard in the opening session from many speakers who talked about non-power as an emerging area of activity. The Council is preparing conclusions, so we get member states hopefully to back the idea to work in this area, and it is looking like that this agenda would have a very big M in it, in the sense that there seems to be a particularly important need to look at the medical field here again, to bring together the pharmaceuticals work, the medical devices world, and the radiation protection world. So we hope that in terms of securing radioisotope supply, radiation protection and safety for medical staff and patients, innovation and human resources and capacity building, we can perhaps add a bit of value in the future. The other area where we have been adding provisions in the BSS is natural radiation sources, and in particular the requirements to establish national radon action plans in the member states. Now, obviously, they will look different depending on the exposure situation, but it's also clearly one of those areas where radiation comes literally very close to people and literally very close to their interest. And it is an area where I think where member states, beyond transposing the law, can learn from each other and can develop, and research can help develop approaches, particularly about communicating risk, but also about mitigating risk in terms of some of the well-established good practice, particularly for older buildings and older sites. And then emergency preparedness and response. Now, I've left that for this directive because it's more legal presentation here, and the strengthened provisions are largely in the new Basic Safety Standards Directive. But few people are perhaps aware that the directive contains very specific provisions obliging member states not just to develop emergency plans, be prepared, and so on, but also do this in a way that there is close cooperation internationally. And what we mean by internationally is not just internationally, but a very, very close link of emergency plans regionally, across borders, and between member states. And this is an important area. This is an important and very strong provision of the directive, which is something we will, with the member states, have to look at as a priority area when we look at the transposition of the BSS directive, which is a little bit behind the Nuclear Safety Directive simply because it came into force a bit later. But when we look at the provisions of the Basic Safety Standards Directive, I think it is very clear that the implementation of the requirements in emergency preparedness and response will be a central part of what we will be looking at. So there's more in the slides. Needless to say that there is a role of the European Union more directly in this. We, of course, have provisions in place as part of the Euratom legal framework to organize early warning and communication between member states. We are monitoring radioactivity, and the systems like Euradwaste come into place into an emergency mode when something happens. But also we have legal provisions in place to regulate radioactivity in food and feed following accidents, be it outside the European Union or inside the European Union. We can pursue this if you're interested, but I think it's important as part of the overall framework. So what we would say, and we would say that, but I think it's clearly an achievement over the last 10 years that the Euratom legal framework has provided ourselves with possibilities to really look at ensuring a high level of radiation protection, nuclear safety across the European Union. As I said, member states are different, they're taking different approaches, and it's important that the different approaches at the same time still lead to this high level of safety standards, which is so important in the acceptance of the technologies, which has been discussed also over the morning. Both of the big directives, but also the waste directive, which will be presented afterwards, represent significant changes in this legal framework. And so the process of bringing this into member state law, their directives, so they have to be transposed, is a process which, while it should have been finalized, it's now entering its final phase, and we have conformity checks underway, as it is called, transposition checks, which should help us to understand how member states are doing. If things are not doing well, we will have to take member states to courts, but that's perhaps not the main purpose. But the purpose is to identify areas where, by working together, also we can help member states in taking these provisions forward. Our provisions, as far as we can see them, and certainly the provisions of the BSS, which come so much out of the development of science, are dependent really on research outcomes. So when the organizers felt it was useful to have a presentation on the directives to kick off this part of the conference, I would say from our perspective, it's equally important for us to hear about the development of science, to understand how the development of science would have to influence the legal framework. So I'll leave it at that. I realize I was very superficial. I went very, very fast. But I did go through, what, Massimo, 400 pages, I think, of printed official journal of the European Union. And if I had read that out, it would have been much worse. Thank you very much. And if there are any questions, I'm very happy, together with colleagues, to address them.
Thank you very much. You have a gift, Mr. Mikhail. Our second speaker on status of EU Euratom directives, Mr. Director Nuclear Energy Safety, and Mr. Massimo Cariba. Sir Director, please.
Thank you very much. Thank you very much, Chair. Good afternoon, ladies and gentlemen. I will try to do something very unusual for me. I was a little bit tricked in this conference because I was told to talk about nuclear waste, whereas my natural subject would be nuclear safety. So I will try to do my best in addressing that. What do you need when you want to make a policy? You need legislation, you need research, and you need money. I think that these are the three elements that you need when you need to bring something forward. In the Commission, the situation is a little bit sparse. You know, we from the Energy Directorate, we do the legislation. The colleagues from DGRTD, they have the money, and the private sector has to have the investment that comes in order to realize the things. This is the triad that has to work in order to progress. Now, this directive comes just after the Nuclear Safety Directive, let me say for historical reason. And contrary to the first Nuclear Safety Directive, it is a little bit more technical than the first one, because it has one element which is called national programs, which we can discuss a little bit in details a little bit later on in this presentation. We had one report on the status of the implementation of this directive in 2017, and we have a second one which is in the making right now. I was asked whether I could anticipate some of the findings of the second report. I'm afraid I will not, so I'm going to disappoint you immediately. So, three main challenges on this directive. One is sustainability. So we use nuclear energy now. We need to handle the waste that is generated from that. Safety. Holistic approach to the whole nuclear cycle and the safety of the waste is, of course, one of that. And the public information and participation, because without that you cannot manage a nasty program like a nasty problem like the one of handling nuclear waste. So why do we do this? Well, the first thing is to protect the European citizens. But if you look a little bit deeper, one of the reasons why this is done is also to ensure that industry and society fulfill their responsibilities. And this, I think, is very important. Now, in the division of responsibilities between the EU and member states, whereas there is a European framework, the responsibility of implementation stays with the member states. And this is where the power of the legal instruments becomes strong, because the legal instruments in time, not immediately, but in time, reduces the differences in the implementation between the member states. One of the major things to do when you want to regulate a sector is also to identify clear roles and responsibility of the people. Who has to do what, and hold the people accountable when things are not done. And the next step is, well, you can have policies, but you need to turn policies into programs, and you need to turn programs into projects if you want to implement these. And this is what this directive is all about. So I was telling you about the division of responsibilities between the Commission and the Member States. Let's start with the Commission. We are responsible for the implementation of the treaties. We make legislative proposals. We have the legislative initiative, which is at the moment, let me say, absolute in the Euratom framework. The Commission is the only instance that can initiate legislation. And then once this legislation is adopted by the legislator, which are the member states, the Commission has to ensure that there is an appropriate implementation of the legislation. And implementation means two things. One, that there is a legal framework in the member states that corresponds to the objectives of the directive, and two, that there are actual actions on the field that implement the directives de facto. We also have, how can I say, less formal roles, like facilitating dialogues between the member states and between the different institutions that takes care of it. And also we go down, let me say, to the more technical field in order to do that. So what do the member states do on the other side? Well, first of all, they have to establish the national policies that correspond to the objective of the directive, as I said. The second, they have the ultimate responsibility for the management of the radioactive waste on their territory. And there is a slight difference with the safety directive here. You know, safety directive, most of the people who feel concerned are the ones who operate nuclear power plants, to lesser extent to people who operate research reactors, wrongly, because they are very concerned by that. But the nuclear waste directives involves all the 28 member states, because radioactive waste is generated everywhere and not only by nuclear facilities. So this is a quite different framework that you have in between the two pieces of legislation. Now, the directives gives a number of principles which have to be implemented in the national policies in order to have a result. And the first is avoid. Don't generate if you don't need to. The second is reduce. The third is reuse, recycle, and recover. Use a graded approach for whatever you can do. Treat the waste, and then dispose of what is left. And I think that what comes out of the first Commission report is quite interesting, in the sense that there has been substantial progress in the EU as a whole as far as low and intermediate level waste is concerned, but this doesn't transfer itself into the picture for the high level waste. So this slide, which maybe is a little bit difficult to read, is one that shows what comes out of the first reports and what are the additional efforts. But if I can say it in two words, as I said, high-level waste disposal and financial resources associated to it are the two main issues which need to be properly addressed in the follow-up. Now, since we are in an R&D conference, I will show you this slide that shows the obligations on R&D, which is development of relevant technology and research, and the associated article on expertise and skills, which has to be followed up in the national programs. So this has to be implemented in the programs that member states present to the Commission periodically. The first one had to be presented in 2015. But then you go and look at the picture that you see, and what did I say? That it was 28 member states that had the problem, and then when you see what are the national programs on R&D in the different member states, you see that there is a lot of blue on this map. So translated in plain words, this means that there is lots of work to be done as yet. And the other picture that comes out from the first report, it's this one, which is the one on deep geological disposal. Now, we are in a situation in the EU where I think we have to be, first of all, proud, because I think we are first in the world. My Finnish friend tells me that by 2024-2025, the Onkalo repository will be in operation. And I wonder whether this will have a effect on the programs and the policies of other member states. Because what you see in this slide, you see that there is an accumulation of programs around 2060. And this is a little bit the weak part of the picture that we have here. So will the fact that repositories start in Finland, then in Sweden and in France, enter in operation will lower this barrier and will lower the wait-and-see attitude that some member states have? So for me, this is an open question. We will see in the second report if some of this planning has changed, but I'm not so sure that this will be the case. So with this, I thank you very much for your attention. And I will be glad to take questions if there are any. Thank you.
We pass on radioactive waste management, and then I'll invite Monsieur Pierre-Marie Abadi, le CEO de Andra France.
Thank you very much. Good afternoon, ladies and gentlemen. I'm very impressed, very honored and very impressed to make this presentation in this theater. I don't pretend to make the show, and it remains a challenge to, in 30 minutes, to make a presentation about all the progress, achievement of the last years in waste management. We prepared the presentation in 3 parts. I will start with waste produced in operation, either low-level or high-level waste. Then in the second part, I will move and show you some insights about dismantling and decommissioning, and in particular the new challenges we have to face in this field. And everyone should remind that whatever you are thinking about nuclear future, you have to deal with waste, and in particular waste coming from the decommissioning. And this is really a common challenge, whatever you are thinking about nuclear. And in the third part, I will make some short remarks about waste coming outside of the nuclear industry, I mean sources and norm, because it is an old but also an increasing topic, also in the framework of the new directives that was presented. To start with, on a global level, about nuclear waste coming from the nuclear industry. In the world, you have more than 446 reactors in operation. You have some newcomers, 4 newcomers, new country, entering in the nuclear production. So you have really an industry that have to deal with waste on a global level. Concerning low and intermediate level short-lived waste, those waste have been properly disposed for many years now, with different concepts that you find on these slides. You have surface disposal, it's the case in France, it's the case in Spain, one will be open in Belgium. You have also shallow disposal in Slovenia, for example, with this kind of pit. And you have underground disposal in Sweden, Finland, typically, also in South Korea. Those concepts can be different, but they are all mature and all well managed. The differences can be explained by geology, of course. It's the case in Sweden, where they have only granite. It can depend also on the history, the culture. Where you have in mining culture, it's not the same thing that in a country where there is no mining culture anymore. And one important criteria from my perspective is the size of the national nuclear program. Because it's clear that it's not the same challenge when you have to deal with 8 reactors in Sweden or with 58 reactors in France in terms of industrialization, in terms of accident risks, if you have to manage an underground facility, etc. So it can explain the different choices that are made in the different countries. But basically, all those concepts are now well managed and mature concepts. Of course, there's still room for an opportunity for innovation and optimization. I will come back on that later when I will talk about decommissioning, but basically it's mature technology. Yes, concerning high-level waste and spent fuel, it depends on the political choice that has been made in terms of reprocessing and cycle, it remains a challenge, of course. It is a challenge with significant progress in the last years. It was explained by Mr. Gariba concerning the three frontrunner, France, Sweden, and Finland. I will come on that later. But basically, in this field again, there has been much progress on the scientific field for the last 40 years. For more than 40 years, many different scientific research competencies have been mobilized, mainly on long-term safety, and now we have the scientific knowledge, they are available, feasibility has been clearly established, and science and research are more and more oriented on technological topics, industrialization and operational safety. Because before having long-term safety, you need to have, first of all, operational safety when you operate those facilities. And now, if there is, and there will remain, political debate, social debate in society, they are really more oriented on ethical questions than really scientific questions about geology. It's more a question choosing between geology and society than really having a scientific debate about the scientific aspect of those projects. So where are we now on a more national overview, in a more national overview? As I was saying, there are three countries that are, I would say, the front runner in this field and that have a detailed design and are applicating or having already a license for construction. It's very important to say that we are three frontrunners because I wouldn't be very pleased to be completely alone as a French in this field. And I think exactly the same in Sweden and Finland. And to be three projects more or less in the same dynamic, I think it's better for everybody. So Finland has a construction license for now 2 or 3 years, and they started construction. They have other steps in terms of licensing for the operational and nuclear part, but they started construction in Onkalo. Sweden has applied with a detailed design for a license in a quite complex regulatory framework with both a nuclear and an environmental licensing process, which remains a bit complex because it had some agreement from the nuclear part and some still discussion from the environmental part. But as far as I understand, they expect to go a little further in the next month. And France is just about to complete the detailed design we started in 2011 for the end of this year. And then in 2020, we will applicate for the licensing process to the Nuclear Safety Authority, so in 2020. Other countries, and these are also on this slide, are restarting or implementing a siting process. For example, in UK, they restart at the end of 2018 a siting process on a very broad base in UK. Switzerland is implementing also an impressive program based on a roadmap, a very strict roadmap, and a very strong democratic process. I would say in a very Swiss way of life, because there are many interactions with population on all the impact and the aspect of such a project. And other countries are also trying to restart or implement a siting process. I'm thinking of Japan, of course, which we started the process 1 or 2 years ago. Belgium, which has made a long process with its laboratory. And more generally, there are around the world several underground research laboratories, Belgium, Hungary, Switzerland, Japan, which are very precious from a scientific point of view, but also from a political point of view to have something to show to the stakeholders concerning deep geological repository. But science and siting is not the only challenge that we have to face. And from France, I can really confirm that because we are more in an implementing process now with design, conception, and then licensing. And those phases also, and this next slide, are also very challenging. Most of the time when we are talking about deep geological repository, we are talking about policy framework, we are talking about site evaluation, science, site selection, characterization, and then we are thinking that because we are relying on very robust technology, design, construction, permitting will be an easy task. It is not absolutely not the case. Those projects are always very, very long-term projects. And it has many implications. Implication in terms of development and construction. Some part of those facilities will be built in a few decades, so it is a constraint, but also an opportunity in terms of innovation. And long-term operation, probably more than a century. It's the case in France, it will be the case in Germany. So more than a century, it has implication in terms of project management. The first one is that you have to remain very flexible, very adaptable to technological innovation, of course, but also to policy change, energy policy change, lifetime expansion of nuclear power plant, evolution in the cycle policy, reprocessing, no reprocessing, fourth generation, no fourth generation. So you have really to be very flexible and adaptable in the implementation and the management of your project. It has also implication in terms of knowledge management, because it means at least 4 generations, I will even say globally 5 generations, because we started 25 years ago, where I really change in terms of knowledge management, not only within our institutions, typically my agency or in research institutions, but globally in the community, there is a real change of knowledge management on the very long term. And the third challenge is that every phase is a challenge. Every change of phase is a challenge. When we started to make design, we had to change the agency to adapt it itself to engineering. And we had 7 years of engineering, which will finish at the end of the year, this year. And implementation, construction is another change, and that we know that we have once again to change to become a contracting authority, a nuclear operator, in front of nuclear safety authority, and it will be also a great change. So there is much to do, phase by phase, and many challenges to solve. This was my first part on low-level and high-level waste from operation. Now I would like to move to new challenges linked to dismantling and decommissioning. Mainly, we're talking about low and intermediate level waste, and mostly short-lived. I don't take in discussion the very complicated facilities from the research sector. But mainly, most of the waste that we have to deal with are coming from NPP, and they are mainly low and intermediate level waste. So, from themselves, there is no scientific change by themselves. They are not very dangerous, they are intermediate. But the process has to be industrialized, and we are facing with huge quantity, sometimes also huge diversity, with change in terms of characterization. And there is a question more globally of optimization, industrial and environmental optimization in terms of decommissioning strategy and disposal concept. And we have to find this optimum in terms of a social optimum, in terms of budget allocation. And in this field, one of the challenges, sorry, it shouldn't be white. So it's one of the difficulty is the incertitude in terms of amount of waste. It is linked to question of characterization, but also linked to safety requirements, depollution targets, and disposal strategies and technology. Do we sort the waste? Do we monitor them properly? Do we reuse part of them? Do we recycle a part of them? Or do we put them all in disposal directly? This question of quantity, this question of global strategy has to be solved if we want to find this optimum I was talking about. Of course, a source of optimization could be like in non-nuclear waste management, to implement reuse and recycling strategy. UK has been a leader in that field because it had many constraints in terms of facility in UK. But for that, you need really to reuse materials or waste outside of the nuclear industry. It's a question of clearance level, which is a difficult topic. It's not only a question whether you have or you don't have a clearance level, but because even when you have clearance level, it is more and more difficult to implement them. Every year, you are asked more control, more monitoring by safety authority if you want to obtain the clearance and the reuse outside of the nuclear field. So the question is really a question of social acceptance. Typically in France now, we have a national debate, and a part of the discussion will be about social acceptance of reusing old materials outside of the nuclear sector. Social acceptance and demonstration how you are controlling the waste, the characterization of the waste, and how you are building confidence. And in particular, if there is a failure in monitoring and controlling. That is partly a technological question, and there is room in this field also for improvement research on technological field, methodology, probabilistic approach, pre-treatment in relation with the regulatory framework. One specific focus on a specific category of waste that we call the low-level, long-life waste. Basically, mainly, we are talking mainly about historical waste. Typically, graphite coming from the graphite gas called NPP, or radium-bearing waste coming from the chemical industry. The question on this category of waste is that they are not very dangerous, they are really low level, very comparable with waste that we are putting today in surface disposal. But they have a long life. So it means that after 50,000 years, they can remain radioactive on a certain level. So we have to find a proportionate solution which is not absolutely the deep geological disposal, which is too much, but can't be the surface disposal. So we are looking around something, a proportional option that would be a low depth, a shallow disposal. But how to make a concept and demonstration, safety demonstration that is acceptable for this kind of waste. I was talking about historical waste, so there are not so many waste basically. Graphite, it is for the country, UK, France, that has been operating graphite gas called NPP. Radium-bearing waste, it is linked to specific sector of the industry and the chemical industry. But in reality, they are not alone, those waste, low-level, long-life waste. They have some cousin, some other members of the family. A part of old waste that are low-level but bituminized coming from the research sector, but also some uranium-bearing waste, some depleted uranium, which is considered today as a material, but could be one day considered as a waste, and many norm, that is radioactive waste coming from the industry. So the quantity of the problem must be much larger than the original graphite and radium-bearing waste we were considering a few years ago. And in fact, this question is much larger and is really quite a complicated question. When we are talking about shallow disposal, technically there are some different concepts. You can imagine an open pit and with a cover, man-made clay cover after. You can imagine also on a low depth an underground drift a few dozen meters under the surface. But it's not that point that is essential. The essential point is that a shallow disposal, which could be a part of a portfolio of options to deal with those waste, is an intermediate solution. It means that it can be very safe at the beginning, but it can't prevent, in 50,000 years, it can't completely prevent erosion and intrusion. So there is a part of scientific question, but also a question which is a question, more social question, which is a kind of remaining risks you accept to transfer to those long-term generation in 50,000 years. This is the first question. The second question is the budget allocation that you are deciding today for those waste compared with other use which could be have more priority in terms of radioactivity. And the third point is the kind of national and debate you have to have with the stakeholders of any kind to build and to co-construct a common strategy. I insist, and I will stop now on this category of waste, because it's not only a question for the nuclear industry, it can be more general for a large part of the industry which has waste with a certain level of radioactivity. And it's directly linked to the evolution of the directive framework of the last years. To finish, in my third part, I would like to give some remarks about waste coming outside the nuclear industry. I'm thinking about norm and sources. And one shouldn't forget them, because for them, the context is quite different. It's quite different because they are produced in many, many different countries by non-nuclear industry and non-nuclear country. It means that they're present in many countries with low and even sometimes no nuclear culture. So it's also a challenge and an opportunity for our community to find and to help to implement proper options for this waste. Proper options, it means safe, environmental safe, but also affordable and very simple to implement in countries with no nuclear culture. There has been already some international cooperation in that field. I'm thinking particularly of a working group by the International Agency in Vienna. My agency is taking part in this work. There are also work at European level on that field. It's really essential to be able to offer solution for those category of waste. Sources, but also norm in relation with my former point. I'm coming now to the conclusion. You will see in the slides, but I will not comment then again, in the conclusion, a summary of what I was saying about a low-level waste, high-level waste, and the new challenges in terms of decommissioning. And I will finish with two remarks on cooperation. Of course, there is a strong need for international cooperation. On a multilateral approach, with IAEA, of course, NEA, with the European Commission, it's quite essential to have frameworks, to have common standards. It is also essential to have bilateral cooperation with other countries, other agencies, in order to have benchmark, but also in order to be able to explain every time the differences between our different projects. Because you saw that there are some different strategies. Those differences can be explained. They can be explained by history, by geology, by industrial dimension and aspects, but one has to be able to explain. Because we have all a common responsibility, and at the same time we have a national responsibility. And I will finish with a last remark, which will be linked with other session in this conference, which is the involvement of the European Commission in terms of research and development. This support by the European Commission is essential. We move progressively to a much more integrated and strategic approach, and EURAD is really an achievement. It is an achievement, but also a new starting point. And I wanted to finish by that. We're talking about that with Christopher Davis, because it's really a common involvement of the national member state and European Commission, which made it possible to launch this initiative of EURAD. And what is new in this program, from my perspective, it is that it relies on a few essential principles that are important for research and development, but more generally for waste management. First of all, to deal with all radioactive waste, it's essential to have the complete scope in order to implement proportionate solution. The second point is to have a comprehensive overview of the treatment, of the different treatment routes, pre-treatment, treatment, and a final disposal. And the third point is to have a federation of all the actors. It means, of course, waste management authority, regulators, national authorities, but also TSO, research institute, and links with industry and the civil society, because for every time, at the end of the day, it's also a question of social acceptance and understanding by the population and stakeholders. Thank you very much, and I'm open for questions during the panel. Thank you.
Thank you, Monsieur Abadi. You're exactly in time. The next presentation, Mr. Andrew Orell from EIA, Section Head of Waste and Environmental Safety. Mr. Andrew Orell, about Artemis. Please, sir.
Thank you very much. Good afternoon, everyone. It's a very great pleasure to be here, in particular in this unique setting, which, with apologies to William Shakespeare, I am compelled to ask, to be or not to be safe? That is not a question. So, over the next few minutes, I'd like to provide you an overview of the IAEA Review and Advisory Services, the Artemis Radioactive Waste Management and Decommissioning Review Service in particular, and how this service has been manifested in support of the European Commission's Waste Directive. I'd also like to take this opportunity to recognize the support and the extra budgetary contribution of the European Commission to facilitate the development and implementation of the Artemis Review Service, as well as their much appreciated support of providing observers in each of the Waste Directive reviews. Thank you, Michael. To begin, since 1957, at the dawn of the nuclear age, the International Atomic Energy Agency, or the IAEA, has sought to accelerate and enlarge the contribution of atomic energy to peace, health, and prosperity throughout the world. Among its many functions granted by the authorizing statute, the IAEA seeks to foster the exchange of scientific and technical information on the peaceful uses of atomic energy, and to establish or adopt standards of safety for protection of health and the minimization of danger to life and property, and to provide for the application of these standards to any of a member state's activities in the field of atomic energy. However, an unavoidable aspect of enlarging the contribution of atomic energy is the concomitant need to efficiently and safely manage radioactive waste and spent fuel, including that arising from the decommissioning of nuclear facilities. As a part of fulfilling its mandate for the promotion of nuclear energy and safe radioactive waste management, the IAEA offers the member states numerous expert peer review services related to the peaceful uses of nuclear science and technology. Indeed, the IAEA offers its member states a wide array of review services in which an IAEA-led team of experts compares actual practices with IAEA standards in, for example, nuclear safety and security, energy and safeguards, or even the health sector. The review services noted here, which are shown in approximate order of popular demand by the member states, covers the whole of the nuclear fuel cycle, each more or less focused on a particular aspect of the adoption or consequences of nuclear technologies or nuclear power. Some review services focus on the regulatory body, others on the operator or technical service organization, and still others concern themselves with the whole of a member state's strategy and policy. Certainly some examples are the OSART reviews, which look at operational safety, the IPASS advisory services, which look specifically at issues of physical protection, the IRRS missions that take an in-depth look at the function of a regulatory body. But I'm here today to discuss one of the more recently formed review services, and that is the Artemis. So what is Artemis Review Service? Really, only the name is new. Building on many years of experience in conducting peer reviews in the field of radioactive waste management, decommissioning, and remediation, it was decided some years ago to give a brand name recognition to the organization of these reviews and to distinguish it from the other review service subjects. And thus the Artemis Review Service was launched. As the whole of radioactive waste and spent fuel management, decommissioning, and environmental remediation are organized in two separate departments within the IAEA, those being the Department of Nuclear Energy and the Department of Nuclear Safety and Security, the respective Deputy Director Generals of each department drafted and signed an internal office memorandum to officially launch Artemis in 2013. Based on the IAEA safety standards, technical guidance, and international good practice, Artemis aims to assist in improving organizational performance relating to the issues under review in member states and to contribute to an increased national and international confidence in their activities. Artemis is structured such that, based on the request of the member state, a review can be organized around any of several domains, such as national policy, disposal, decommissioning, remediation, etc., and scoped to any of several topics, such as implementation of safety, technical programs, waste inventories, financing schemes, etc. The point is, we have a high degree of adaptability for the review mission to ensure each is tailored to the unique circumstances of the member state's realities for providing safe spent fuel and radioactive waste management, while still ensuring all pertinent aspects are addressed in the review. An Artemis peer review is managed according to a set of well-developed guidelines and practices. In consultation with the requesting member state, IAEA staff draft a terms of reference that helps guide the review scope, aids in the selection of approximately 3 to 7 independent international experts to serve as the review team, and sets the stage for all the logistical and administrative issues to be dealt with. In general, we expect the requesting member state organization to complete a self-assessment and to provide a priori to the review mission itself documentation that supports the review scope. Once all the preparatory matters are addressed and the review team has had a chance to consider the review documentation, we schedule the on-site review mission to occur over the course of about a week of very long hours, which ends with a draft of the review mission report before the exit meeting. Over the next couple of months, we finalize the review mission report and provide it to the member state counterpart. As with all such mission reports, we strongly encourage the final report be made publicly available. As a review report is the final product of the Artemis Review Service, I'll note that all reports are comprised of only recommendations, suggestions, and the identification of good practices. Recommendations are made when there is a clear shortcoming in compliance with the letter or intent of the corresponding requirement of an IAEA safety standard. And in the case of the EC Waste Directive, recommendations may also be used to identify issues over compliance with the requirements of the directive, which we'll look at in a few moments. In principle, recommendations carry the expectation for action by the member state. Suggestions are identified where there is opportunity for improvement not directly related to inadequate conformance with an IAEA safety requirement, and the member state may want to consider new or different approaches to an issue. And finally, good practices are those aspects that the review team wishes to encourage the member state to maintain and that are worthy of sharing with the broader community. We maintain a public-facing website for all of the Artemis activities, and I encourage anyone with more interest in the details to make their way to the website address noted here. There is also a contact point where anyone may request answers to specific questions or consultation on the review process overall. From the beginning, the Artemis Review Service has been mindful of the European Commission's Council Directive of 2011, or simply the EC Waste Directive. The EC Waste Directive was adopted for establishing a community framework for the responsible and safe management of spent fuel and radioactive waste, including that arising from decommissioning. Yep, that's article. Notably, among its many requirements, the EC Waste Directive calls for EU member states to invite international peer review of their national framework, the competent regulatory authority, and/or the national program. The call for international peer review is with the expressed aim of ensuring that a high standard of safety is achieved. The outcomes of any peer review shall be reported to the Commission for their own purposes and to the other member states, and may be made available to the public, barring proprietary or security concerns. This directive set the stage for a number of Artemis peer review requests, to which I'll provide the status of in a few moments. In the previous slide, I noted the EC Waste Directive calls for a review of 2 or 3 components, which are elaborated in additional articles of the directive. Thus, in response to the Waste Directive review request, the Artemis reviews need to be mindful of these specific requirements and expectations for a review of these components. In the case of the national framework, the Waste Directive expects it to provide, and the Artemis review will consider, whether there is the existence of a national program and national policy, the arrangements for safe management of spent fuel and radioactive waste, the existence of a licensing system, including control, inspections, and enforcement, the allocation of responsibilities to licensees, the requirements for public participation, and of course, financing. The scope of this national framework review is incorporated into the Artemis terms of reference between the requesting member state and the IAEA. Got cut off there. Likewise, with the review of the competent regulatory authority, we must contemplate their independence from other organizations which may have a more promoting role, and whether the regulatory authority has the necessary legal, human, and financial resources to effectively implement its regulatory function in assuring safety. Occasionally, the IAEA's Integrated Regulatory Review Service may have recently reviewed in detail the member state's regulatory authority. And if so, the Artemis review can be structured to take credit for that review or vice versa. As with the other articles, the Artemis review is structured to confirm the expectations of the national program, ensuring in part that the national policy has clear objectives with milestones and timeframes for implementation of spent fuel or radioactive waste management policy. That there is a clear current and projected waste inventory existing, including that arising from decommissioning. That concepts and plans exist for spent fuel and radioactive waste from generation to disposal, including the post-closure period of a disposal facility. That any R&D needs are identified, and that assessment of cost and financing schemes do exist. As you can see, some of the requirements are moderately subjective, and others are quite objective in their expectations. The Artemis reviews must also consider providing consistency in the rigor of the evaluations among all member states. So where are we now with the Artemis reviews and the Waste Directive ones in particular? Shown here are the Artemis reviews completed and requested to date. Of the 28 EU member states subject to the Waste Directive, we have completed 6 thus far. 18 are in formal planning or in discussion on their requests, and only 5 are still need to be scheduled once requested. While the Waste Directive is a major impetus for requesting Artemis reviews, the Artemis Review Service is also open to all member state organizations, government or commercial. The reviews highlighted in red are just such reviews. Sogin, the Italian organization responsible for decommissioning, has completed 2 requested reviews on decommissioning approaches and planning. and the Brazilian Euradwaste organization requested and completed a review of waste characterization methods. Unofficially, we know that Slovakia will request an Artemis mission sometime in 2020, and Austria will probably request sometime in 2022. And finally, it's reasonable to ask, so what have we learned thus far? The European Commission is responsible for deciding the general state of affairs regarding the safety of spent fuel and radioactive waste management practices across the EU member states, and based on the national reports of their member states, possibly augmented with the results of the Artemis Waste Directive reviews. It is a bit premature for the IAEA to make broad generalizations on whether the objectives of the Waste Directive are being fulfilled across the EU. However, I do note that thus far, all Waste Directive member state reviewees have taken the requirements and expectations of the Waste Directive seriously and with deliberate intent to promote a high level of safety. This is clear, even though each member state has unique conditions and circumstances in the implementation of their national framework, the competent regulatory authority, or their national program. Despite these natural differences, the IAEA is working to ensure all of the EC Waste Directive reviews provide a high standard of quality and efficiency in terms of cost and time. Further, it is the desire of the IAEA that we deliver a consistent review experience in the planning, performance, and reporting of the Artemis reviews, and that the review results are of high quality, with value to both the member state and the European Commission. I look forward in the coming 2 or 3 years, when all of the Waste Directive Artemis reviews should be completed, to providing you even greater assurance that the safety of spent fuel and radioactive waste management is well in hand, with demonstrably high levels of safety achieved thoroughly and completely across the member states of the European Union. Thank you very much for your time and attention.
And now, on the last part of waste management, radioactive waste management, Mr. Christoph Davies from Euratom, Fission Project and Policy Officer. Sir, please,
Good.
your presentation.
Thank you. The aim of this presentation is to take you through the various stages and steps that the Euratom program has gone through in recent years to justify its evolution and also to prepare for the future. You may wonder what this figure means. 44, it may be the age of somebody. If you're 44, you're still quite young. But 44 is the age of the Euratom program. And once you've existed for 44 years, if you're a human being, you're close to retirement. I'm not saying that the Euratom program will withdraw, but we need to prepare for the future. This is the spirit of this presentation. Anyway, the basis for the intervention on research and training is the treaty, which says that we need to help member states find solutions. And then also, we also can stimulate joint funding from member states, people, and enterprises. This is the basis for intense and integration collaboration at EU level. Now, coming to the current framework program, this is the objective, which is here to say we need to strengthen research in the nuclear field, to avoid duplication, retain critical mass, and ensure that public funding is used in an efficient way. So this is the overall objective and rationale. Then when you look at the domains that the member states have agreed that the Euratom should cover for this current framework program, is continue to do research on deep disposal. But when you look at it, it says remaining key aspects, which could lead to the questions, is when you've achieved this, is there a role for Euratom? And then the second topic is to address all the other waste streams for which there is no industrially mature process. And thus, this is an opening for Commission to prepare for future activities. Of course, I mean, this is standard. In the program, we've been covering all the types of waste, from low-level, intermediate, and high-level waste. I have separated the low-level and high-level waste because we have supported these different categories of waste in a different way over the framework programs. And then you see in the boxes all the activities that are allowed for such activity. I mentioned also decommissioning, which we used to support a lot. I'll come back to this also. On this slide, you have an overall picture of the evolution of the different budgets. So we started in 1975, and then we gradually increased the funding up to the mid of the 90s, where this budget was split between low-level and intermediate-level waste and high-level waste. You can see also that we had a significant budget on decommissioning, the orange histograms, and this was gradually diminished and stopped for at least 2 or 3 framework programs. And the rationale for this is that it was considered in the early 2000s that this domain was already an industrial process, and then the need for direct research was not supported by the member states because this was an agreement of the framework program. But you can see that gradually we've picked up the budget. Okay. Basically, we were also very low on support to high-level waste because there was quite some activities and then it was considered that the science gradually was starting to be mature. I think it's been mentioned by Mr. Abadi also, 40 years of science. But then we start to increase again the budget, and this figure for the current framework program includes the budget for the next work program or the ongoing work program 2019 and 20. And you can see here that we have reopened gradually activities on the decommissioning, in particular the characterization of waste and innovative concepts that is quite competitive. Now, on this slide, it summarizes all the domains of activities that Euratom has supported. You have basically a schematic of an underground laboratory, and then you can see the various fields of activities that we have supported, the far field, the near field processes, the technologies. Performance and safety assessment was central in the 90s, and then public involvement, governance has been supported quite substantially in the FP5 and FP6 programs, also including strategy studies. But all these were based on competitive calls. So we were starting to think that the only competition between projects is maybe not the best way to support research, and then integration of the programs was starting to be advocated with these large integrated projects, which you have here in different logos. For instance, funding, we have here the previous coordinator, Gunnar Bucco, and Lara Duro were doing this. So, I mean, this has been the major achievements of the program FP6. This scheme shows the gradual integration at EU level. The funding, the number of projects which were initially large, 43, and now we've gone down to 10 because we have larger projects, but the average funding per project has increased a lot. Also, the number of participants has been a bit stable, and then the average participation number of participants per project has increased. So you can look at this, it's not very clear from here. Now, the steps in integration and coordination at EC level. You can see at the bottom, it took 19 years to aggregate the different communities, the waste agencies, the TSOs, and the research organizations. We had just an example of first integrating project called NetExcel in 2002 to start to have an idea of if we could develop a common research agenda already 17 years ago. But I mean, sort of the mind of the different communities is maybe sometimes slow to evolve, and then we went to the step of supporting the launch of IGDTP in 2009 with its SRA in 2011, then the support of TSOs, which was also a recommendation of the NEA RWMC committee, and this we have supported in 2 Council projects. Now the Cytex network is launched, and the Eurad Science, we're going to say why it's been launched in the next slide. All this captures the main spirit for integration. So basically on the left hand side you have the 2 framework programs, FP5 and FP6, which I've shown in the schematic of an underground repository. So this is the program objective and EC policy. We were doing science and technologies, industrial implementation in FP6. Then the mandate was to do implementation-oriented R&D again in FP7. And now we are on key remaining aspects, plus the other waste stream, as I have said. Now, on this EC policy, the major change for further integration was a communication in 2011 from the Commission, which was advocated for joint programming. And in the field of radioactive waste management of the Euratom program, we've really taken this on and to really ensure that we go through this process to make sure that we can do this. All these, the bottom, the left-hand side we've seen. In FP7, there was something that was sort of triggering stage for justifying further integration. We had a call on gas impacts on the repositories. And then we had two competitive large proposals from agencies, and then the other side, TSOs. And then the evaluators said, well, this is not on, you need to come together and then have joint projects. So we reopened the topic and we supported a first joint project. Then in FP7, because we were talking about implementation oriented, we were supporting IGDP priorities. And civil society were included in projects, and I can say this was some kind of innovative way, because civil society or social science experts were only involved in the waste projects. So we have been somehow innovative in there. But then when you look at the evolution, the science was quite mature, and then we had GD applications in Sweden and Finland in 2011 and 12. So the Commission thought that it needs to prepare and think for the future. So at the end of this FP7, we had the Euradwaste conference, the previous one. And there were quite a few key messages. Because the geographical disposal and the time scales are very different between member states, and if the Commission wants to be of help to all member states, it needs to adapt its way of supporting not only key remaining issues, because this is not a priority for the lesson match programs. So this means we also said that each repository was a first of the kind, and then each repository has to do its own specific R&D. Because the long time scales, we need to reopen the basic science to update the tools, the models and codes. And then, of course, because of the long time scales, we need to manage and transfer knowledge between generations first, and also between programs. So this is seen from the Commission as a key role. Another issue, this SEC IGD2 was a project supporting the IGDTP platform. And then there was a guide issued called PLANDIS on sort of guiding a program that has not really structured research program on what they have to do at what stage during the evolution and development. And then this also PLANDIS guide plus SEC IGD2 identified that some of the smaller programs and less advanced may not necessarily have a priority today on deep disposal. So we, Commission, we need to take this message on board. This is why we started to reopen the pre-disposal activities. Now, we are Euradwaste 19. I hope that out of the different sessions and the panel discussion, we're going to draw key messages that would support the strategy and orient the strategy of the Commission. Now, strategy and questions at EU level. These are open questions that we are asking ourselves. Is it necessary, and how to integrate waste producers with the geological disposal community? We have managed to integrate the 3 disposal communities, but they work mainly on open science. Whereas when you talk about waste producers, there was an example of this year call, where we had a proposal where 3/4 of the deliverables were confidential. So is this the spirit of the European Union to support research which is confidential? We need to take this into account, whether we accept this then, and is it feasible within a European Joint Programme with the other communities which have open science deliverables. So, then the question is how to ensure long-term knowledge management plan. Of course, as mentioned, Euratom is an old program. We need to think for the far future and also to be of support to small programs, support the transfer to new generations, and so on. So this has been mentioned as a priority when asking for this European Joint Programme. Now we need to, for this, to make sure that it delivers. And then, because we have close contacts with IEA on all these domains, how to organize effective synergy and almost co-creation with IEA. This would be an achievement if we can make a step forward in this domain. Now, another key question is which tasks for non-technical stakeholders? I said that we have been somehow innovative in including social science into the projects, and it has had benefits. But now we see that very often social scientists want to be in all projects. And then we are questioning this demand because usually the civil society want to be in the project to review the work of the others. And this is questionable because if it is a matter of reviewing the project, then they should be part, as we say, in the external advisory group, which is the body which reviews the work. Civil society can be involved in defining what they think should be addressed or what research should be done. But to review the work of others is, to us, questionable. Anyway, we need to look at this to make sure that whenever civil society is involved, we have clear tasks and deliverables associated to it. So, in conclusion, the raison d'être of Euratom, of course, is to help member states develop solutions, because they have, each of them, responsibility to do this. Possibly jointly, when there is a possibility to develop a treatment process or facility, why not? But we have not done it yet, and this could be a domain. So I think that we can ensure together synergies and effectiveness between all actors. The coordinated, which we call non-competitive R&D on open science in the European Joint Programme is considered from the European Commission the most effective way. We need to ensure the management of knowledge, do also cutting-edge science and knowledge transfer between member states, provision of a next generation of scientists. We need to also think of how to involve academics, because in this scheme of the European Joint Programme, the beneficiaries are those who are mandated by their national program, their governments usually, or ministries, but not all the academics are involved. And we need to think whether we can find solutions to involve them, especially on long-term knowledge, science, and then education training. So, and then the final question or conclusion is contribution of non-technical stakeholders in our R&D and the European Joint Programme need to be defined. Now, this is somehow concluding. Euratom Programme is 44 years old. In next 44 years, we will be in 2063. Shall we still be there? We will see this. Because when you look at the time scales for implementation, you have, as it's been mentioned already, a number of countries that have this target date. So if the Commission and Euratom can help these countries to meet these targets, then it would be great. All these dates are not the exact dates of the first national report. Some of them have been adapted via the dates announced by IGDTP. So this is, to me, the spirit of the European Union. Together, we can reach further and farther. Thank you for your attention.
Thank you very much, Mr. Christophe, for your interest and presentation.